Okay, I think that's probably a good amount of time. I see some other people joining, but I want to thank everybody for taking some time out of the day to join us. We're going to cover a new product, a new app in the Onshape community called CADWOLF, and we'll show a little bit of Onshape, but mostly we want to show what these new capabilities are and how it can help you get your job done. Why don't we make sure that everything is functioning correctly? It's always a good idea. If you could raise your hands, that will tell me in the GoToMeeting um, console, that will tell me you're hearing me. So raise your hand if you hear me. I just want to, so far, all right, there we go, good. So looks like everything is functioning correctly, which it's always audio that seems to be our hardest part. And what I also want to encourage you all to do during this session is that we want to make this interactive, and I definitely want you to ask questions, but you're all muted, so what you have to do is type your questions. We will answer, and I think that the Q&A at the end of the sessions or during it are always some of the best parts of doing an interactive session like this. So you're going to be hearing from two of us today. Joshua Foxworth is the CEO of CADWOLF, and this is mainly his presentation. Josh, you can say hi.
Hello.
And I'm Joe Dunn. I'm with Onshape, so I'm just kind of starting this whole thing off and kind of guide us through to get to the good stuff. So I do want to give a very brief overview of Onshape, just in case a few of you aren't using Onshape or haven't used it. So it's always a good idea. But in general, we want to get into the meat of the CADWOLF functionality and demonstration. So what I'll do is, and Joshua, I'm sorry, I kind of blew through this. Do you want to introduce yourself a little background? I should have said that before I came. Sorry.
No, it's fine. I have a bachelor's and master's in aerospace. My experience is in the space field as a structural engineer. I worked on the Orion capsule for a few years and the Shallow program for a few years as well.
Truly literally a rocket scientist. All right. So a little bit about Onshape is I think it's really good to get a good perspective of where we're at as a company and a product. You know, we launched Onshape about a year and a half ago, and that's how old Onshape is, and we're just starting to build up a very interesting community of partner applications that will let you do a lot of stuff in conjunction with Onshape and in conjunction with the CAD tool. CADWOLF is one of the cooler apps that you're going to be able to do some stuff that you probably didn't think of before. Or you're probably using a different tool right now that this may be a better one to use. But in general, what you should realize, we're about a year and a half old. We're growing really, really fast. And our background is coming from the SolidWorks side of things. I'll probably accidentally say SolidWorks a few times. I was there for almost 20 years, and we felt it was time to start a new company and a new product. It was just the market and the technology and the platforms. We are moving to a world where the computer, you don't install things locally, and you can run on any computer, and it's much more flexible to go wherever you are and use your product instead of being a slave to one install and one huge download and all the things that entails. Our product is designed just like any professional high-end CAD system. We do parts assemblies and drawings. That's kind of the core of Onshape, very typical. It's a parametric, feature-based, history-based design tool. But we are tackling robust, big, difficult problems. This is an industrial strength product. This is not a low-end compromise, do small things with it. We are targeting to build the space shuttle or the next generation of space shuttle. You would use Onshape to do it. This is exactly the type of thing. We want any engineer with any task in the mechanical world to be able to use Onshape. The reason why we started a new company and a new product is that we are able to really do some things that we couldn't do, like, let's say, with SolidWorks. And with SolidWorks, we would update that product once every year, approximately a year and a half. It was a big update. It would take us a year of working on bugs and putting in new functionality and putting it all together, and then we'd have to distribute it to the world. And what winds up happening is that some people upgrade, some people don't. When you do these huge releases, they're buggy. They're by their very nature, when you do so much at once, you can't possibly anticipate all the different ramifications of things. So, most people don't even upgrade when you update these big things because they're worried about the first service pack, SP0. I mean, if any of you are using SolidWorks, you know that you never do SP0, you wait for SP1 and stuff like that. This is a whole nother world. We have had a live product for almost 3 years now for it. It's never gone down, or if it's gone down for such a small amount of time for a very small thing, but it has consistently been up and reliable, and we have consistently updated the product on let's say about every 3 weeks approximately. Major updates come, but they come in small chunks, and they come in very the entire world are getting this new functionality, because there is no install and there is no interruption into your workflow. You just get new functionality, and it is really a refreshing and a very interesting way of doing things. This map isn't complete. I can't keep it up to date. But it's every time we update something, the entire world is on the same version of Onshape, and we're able to distribute it right away. We also made sure that this product runs universally everywhere. That's really the point. It doesn't just run on a Windows machine. It runs on Mac, runs on Linux, it runs on mobile platforms, iOS, Android, Chromebook. We don't, name your product or your hardware platform and your operating system, and chances are you'll just be able to use Onshape. And again, that we had to start from scratch to make this happen. And we've architected this in a very elegant way to really take advantage of these platforms. And it's the full product everywhere, right? So it's a breath of fresh air again. Now, what I'm doing and what we're building is CAD is important, but it's not the entire engineering process. In fact, it's a small part of it. I'd argue it's probably one of the more central pieces, but you need to make sure that your design is going to be performant. It's going to have the right mass property characteristics. It won't break. You may want to do marketing material with it. You may want to do some manufacturing. You have the data, manage your data in some kind of controlled way so that the entire engineering group and actually the whole company can work and leverage the data. So we're looking at this as it's a marketplace, and there is a API, and Onshape is a platform that allows other vendors to add their functionality or add their capabilities to Onshape users, and that's exactly what CADWOLF is going to do. So Joshua, I think it's best to let you take over and describe what CADWOLF is, and I'll just kind of be quiet.
Okay. So if you've ever used MathCAD before, the basis of CADWOLF is very similar to that. It's just a platform that, let's see if I can scroll to the next slide.
Yep, I'll do that.
So in CADWOLF, you simply create web pages that look like a Word document, but you're able to embed equations and things like that give you all the functionality of a programming language. There's also charts, tables. Obviously, you can put images and videos, anything like that in there. You can sort of think of it as Google Docs, but with added functionality of computer program type things. In addition to this, we can obviously share variables with Onshape, and we can read models back in from Onshape. So that is sort of our core functionality, but building on that, we started to develop a bunch of things like part trees. We're going to show a simple example of this, but this is basically just a way to take a really big, really complicated structure and break it down into its individual components and keep track of the progress of each one and the status of each one, and really give you better feedback as to what's happening with each part. And a lot of this is based on the problems that I saw in the space program and what I thought was possible with an online platform. So go ahead and go to I think the next slide is just okay. So there are 4 basic modules, as I call them in CADWOLF. The first is what we call a document, which is where you do your analysis and your write-up and all that. Everything else sort of builds off of that or is functionality to it. What I call a workspace, it functions like a folder in Windows. It's basically a place you can go to add new documents, new data sets or part trees, and access those documents. It's just basically a URL that you can go to and access your data. One of the things that I wanted to do differently about CADWOLF was that instead of having to go to a URL or something that makes, that you can't really identify what you're going to by going to that URL, if you've ever used some PTC products or something similar to that, if you're trying to find something and you don't already have a good idea of where it is, it's very difficult to get there. In CADWOLF, the URL is everything. The URL will look and feel just like you're going to a folder structure, and you'll see that in just a minute. So that's a workspace. A data set is just a simple module you can go and paste or upload a text file, parse it out into data, and then save it, and then you can pull that data into a document and use it as a variable. So if you've got test data or something like that, instead of having to store it on a completely different system and read it into MATLAB or find a way to get it into Excel, you just store it on CADWOLF and you can pull it into multiple documents. I talked a little bit about the park trees already, and the best way to get a good feel of this is just see some examples. So we can go there now if you want to
Okay. So
share my desktop.
Yeah, why don't we do this? One thing I want to do is just go back to Onshape for a second before we get into CADWOLF,
Okay.
while it's on my screen. Just in case you haven't done this with Onshape, we're certainly not going to show a whole presentation of Onshape with the CAD functionality and showing how to create parts and create assemblies and documentation with drawings. But keep in mind, one of the fundamental differences is that this product is it's a collaboration platform too. And so it's like, sorry, it's not full screen. I'll try to make it a little bigger, but think of it like Google Docs, kind of a Google Docs style approach. So I'm in a model, I'm the designer, but I already can see that Joshua's also working on this model as well, right? And he's collaborating with me, and we're working on a single model. We're not creating copies. We're not checking in and checking out. I'm not emailing him some exported file format and worrying about whether or not he has the right format. I know that because we're both using Onshape, it just works. He shared the model with me. We're working together. I can even watch him. If I want to double click on his model, it jumps right to the spot he's at. And whatever Joshua does right now, if he rotates the model or moves his mouse or just stands there without moving anything, I'll see that. But Joshua, rotate the Onshape model a little bit just to show him. So that's him moving around. I'm just following him. And it's just kind of a scratching the surface. But the way we're collaborating together is we shared. He granted me access to this document, and he can always take that access away later as well. So it's a much cleaner, easier way to go when it comes to just working together. Now, I'm going to make you the presenter, and then I think you can take it from here. Okay. So let's switch over to you. All right. So you should be able to share your screen now. Right. All right. So I see you.
All right. Can you see my screen?
Yep.
All right. Let me move some stuff around. All right. So this is the basis of a workspace. As you can see, the URL, this is our examples workspace. So the URL will tell you what module you're in and then the path that you use to get there. So this is just the top level examples folder. It has a list of some of the basic examples. As you can see, this is a emblem for a data set. You got some subfolders. So let's just take a quick look at a basic example. So this is a document. Like I said, if you've used MathCAD, this will be obvious to you what this does. You have text. I call these symbolic equations. They don't actually solve anything. It basically just lets you enter LaTeX and show so you can explain to people what's going on in your document. Here I've put down some equations, and the way this is done, you simply click on whatever item you want to be selected, and then you click what you want to add, and it's added directly beneath it in the document flow. So this works basically top to bottom as a program. So I just declared some variables, entered the name of the variable, just literally type A = 4. It solves. When something changes, obviously everything after it updates. I have a lot of built-in functions, obviously, as like root, power, those sorts of things. And when they solve, they're displayed in the proper mathematical format. Things like vectors, you can select to show the full data here, but obviously if you got a long vector, that's going to take up a lot of room so that you can show them just the size. So I created a couple of vectors and plotted here. So all this stuff, like I said, functions in a lot of ways like a Word document or a Google Doc, and then in a lot of ways like a program. One of the differences between us and something like MathCAD is, since we are web-based, we're able to have a lot of HTML type elements. So here's the same sort of document where I've just used sliders to represent the coefficient values. So obviously you can change one of these. everything updates, plot updates as well. So that's sort of the core functionality. I'm going to just click over to some other documents that I've made. The mathematics of this can get as simple or as complicated as you want. Here's one where we solve the loads on a bar from a direct stiffness method. This is just an image that I've embedded from a textbook. These are some more symbolic equations to sort of explain what's happening. And then I just set values for those coefficients and things, solve the math here. And as you can see, again, it's displayed in the proper format. And the math solves. In the end, everything comes out just as you expect from a computer program. A Gauss elimination, built-in functions used here. Everything's displayed in the format that you would expect it to see. Just a couple more examples. Again, this is just an image. We have integration functions, those sorts of things. So you can see there's a lot of symbolic equations worked into the actual mathematics. One of the things you'll notice is that there are units in this as well. We track units, and so you can add, say, feet to meters, inches, centimeters, that sort of thing, and read all that math behind the scenes. If you try to, say, add a length to a weight, it'll tell you that you're doing that, and that's wrong. Here's one of our more complicated examples. It's the velocity and position of a bungee jumper after he jumps off a bridge. So you can see more symbolic equations to sort of set up the problem. We let it get more and more complicated as we build in more and more things. Here's one of the early differential equation functions without the actual bungee added in. Add the bungee to the equation. It's a pretty long equation, and there's the solution for his position and velocity. So
this is assuming he's latched, right?
Right, yes. So like I said, if you used MathCAD before, a lot of this will look very similar. It is intended to be functionally different, though, in that obviously it's all web-based. So these documents were just created by going into a workspace, hitting a button to say create a new document, and then opening it and adding all these items to it. It's all done interactively. Everything is done by adding a new component from the menu here. If you want to adjust one of your properties, everything's done over here, and we'll show some more of that in just a second. If you want to look at just equations or just text, you can hide certain things. One of the things that makes us different is that we're able to read variables from one document to the next. We'll show how that really comes into use with part trees. You can also use a document as a function. So if you wanted to have a certain solution model that everybody uses to, say, solve for double shear in a bolt, you could basically create a document that explains that, and then people would simply import that document as a function into whatever document they were solving. So where we start to separate ourselves from something like MathCAD is obviously that we integrate with Onshape. So a very basic example of this is the model that we showed earlier, which is just a weight that hangs from a rod and has a fitting at each end. Obviously, this is not something you would design as an engineer, but it's something that we use to sort of show people the basics. So that weight is set up in Onshape by simply, we just simply added the model and the elements we wanted to send the variables to, and then went through and selected what variables we wanted to send to it. So we send certain variables to the weight, to the different aspects, the rod, the bolts, and everything within that model. So what that lets us do is we're going to change the width, the height, and the length of the weight itself. So everything's resolving, and the MathJax is going to update. It takes a few seconds to do that whenever you're doing a lot of stuff. So what we've done here is we've changed the dimensions of that mass that it's holding. And so the design, which is just encompassed in the rest of this document, updates as well. So we changed the size of the bolt, changed the sizes of the fitting, and changed the width or the thickness of the rod. And then once we do that, we can save the file. And after it's saved, all of those variables that we've linked to our Onshape document are pushed back to that document. That's going to take a
My
couple
screen is
seconds.
updating right now, so I'm watching it update
Okay.
in my model. So
Okay.
you
All
can
right.
add
So it
to
tells us it's saved. We can go over to our model, and I don't know if you remember this from before, but as you can see, the weight is a lot thicker now, and the sides of the fitting have thickened up to handle this weight as well. You don't really see it much here, but the dimensions of the eye rod have changed, and the strut has changed as well. So basically, if you were doing this as of right now, let's say you're using Pro-E for your CAD, and you're doing something like even MathCAD, or more likely Excel or something like that to do all this design, because the math of this is not that complicated at all. It's a fairly simple mathematical problem. If you were to change the size of that weight, you'd have to change it in your math and get the dimensions, then go change your documentation to be updated along with it. Then you have to go over to the CAD and make all those changes. With this, we simply change the dimensions, save the file, and since your math and documentation is done here in CADWOLF, and it obviously links directly to Onshape, all that updates pretty much immediately. And you don't have to ever worry about it getting out of sync, which is obviously a problem for any big project. So let me close a couple of these windows. So building on that, we have what we call part trees. So if you've ever done a really big project, especially in the space program or something like that, what you do is you create a part numbering system. And the goal of that system is well, there's several. You want to be able to pick up any part, and it'll have a number sort of embossed on there, or however you do it. And based on that number, you know exactly where that part goes, and you know exactly where you have to go to find its documentation or something along those lines. Conversely, you can look up the number. Whatever number you see in the documentation will tell you exactly what part you're looking at. So our part tree module lets you set up the tree, all of the different, however many nodes of the tree you want, and then what your options for each node is going to be. You then simply go in and populate the tree all the way down to the last level, where obviously it's going to be a unique number. And this is just done through the right-hand menu here. Once you've done that, you can go in and link each part in each system to a different Onshape model. So once you've done that, it'll not only display the thumbnail here, but you can also import the data from that model. Let me just go ahead and open the truss model. So this icon did appear in the truss. That's the icon there, but it's kind of difficult to see what it is. This is just a simple truss where, let's say something is grabbing hold of this top ring and pulling it, and it has to take whatever is attached to this bottom ring along with it for the ride. As you can see, is similar to the hanging weight problem. There's just a rod, an eye bolt, and a fitting there that it connects to. So even this is a fairly simple problem. It's got, once you add in all the nuts and bolts and all the other things, it gets pretty complicated to keep track of the status of each part, how up to date is the documentation. The way that we solve that is each part is given its own document. You can open it here. Let's say the 003 is the design of the strut. If you were to open that document, you can see right away, let's say that you thought the weight was way less than it should be. You can go in and see what your engineer actually did to design it. So you know right away if he made a change, if he was not doing something correctly. So we calculate, as to design the strut, we pull in the density from the model. Then we set the inner diameter of that rod based on the eye bolt it's connecting to. Simply calculate the outer radius based on the weight that it's holding. And those items, the weight and all those things, are pulled in here from other documents. The main document that's driving this is an outside one that we have in the same folder. So in this outside folder here, we've set up the connection points for each of those struts, a factor of safety, and the main item obviously being the design weight. So this D weight variable that you see here, this is pulled into this document and then used to calculate basically the outer radius of this. These similar items are pulled into the other design documents for, say, the eye bolt, the truss, and the fitting. so that when those items are updated, you'll see that these items update as well. The last thing that I would point out is at the end of this, we calculate the weight. Obviously, coming from the space program, everything that you ever dealt with was weight. We call this variable weight, and what that lets us do is go into our part tree and say, let me see the weight for each of these items. So it goes into those documents, pulls out just simply that variable named weight, or the last occurrence of it, pulls it in here, and then for each system that you're looking at, we'll add it up for you. So one of the problems that we had in the space program is that you had a separate Excel spreadsheet where everybody's recording how much their system weighs at the current time. We called it hoarding weight, where you would simply say you're allowed that your component is going to weigh 35, 40 pounds. Well, it might actually weigh a few pounds less than that, but you're going to go ahead and say, yeah, I'm right at where I need to be, so that if something happens, you have to reclaim that weight later. You don't have to change a lot of stuff. Well, in this, you can see real time exactly what your item weighs, and any variable that you want to have in each document you can pull out here. It could be cost, it could be mass, it could be anything along those lines. Since we've linked each of these to a CAD model, we can then go in and pull out that variable from the CAD model itself. So you're going to see these are going to be a little bit different. Hold on just a second here. I think they look a little different now because they haven't been updated. There we go. So some of them are going to be a little bit different because you can just be a lot more precise in the weight of, or in the CAD model is going to be a lot more precise. Like when I designed this fitting mathematically, I don't account for the curvature of the fittings or the any of the smoothing aspects of it. For things like the eye bolt, I simply give it a weight based upon the weight that it's holding. Some of them are going to be a lot more spot on, like the washer, obviously. So this lets you compare the CAD model to your actual model, and plus just gives you real-time feedback. In addition to this is where it really starts to come in more useful. Let's say your boss comes to you and says the design weight is now double what it used to be. So you can go in, change the design weights here, save that file, come back to your part tree, and it'll tell you, okay, these three things are now out of date. Which means that something that they're depending upon has changed. And since the design of these things depend directly on the design weight, they need to be updated. So we'll just give this, I'm going to give this a few seconds extra since I'm running a lot of stuff on my computer. I don't want to step on the process. So all this is doing in the design here, once you click update, it's simply going into this design document, pulling those variables down, solving them, saving the current values, and then resaving the file and sending the new values to Onshape. All right, so once that's been done, we can click this button over here and it'll ping Onshape for those values, which we'll update in a second. But as you can see, the fitting here has redesigned itself. It's a lot thicker, just as in the hanging weight model, and the strut's a lot thicker as well. All right, so these values have updated. So there again, you can pull the weight right back out of the files. You can see they've updated. The weight and things from the CAD model have updated as well. So if you had done this the way it's currently done, where you're calculating things in Excel or even MATLAB, and then you're documenting in Word or PDF, and then you have a separate CAD model which is totally unlinked, you would have to change your design weights and all of your math for all of your different components, then go update the documentation, update the CAD model, and then you're always going to have something else, like in the space program, like a weight table, like I was saying, that you have to go update as well. Where in our case, all that was just done. That's probably days worth of work for an engineer done in just a few seconds. I think that's it. There are a few other, if you want to see exactly how much functionality we have in a document, I can show you a few more examples, but I think you get the gist of it. It's pretty much documentation and analysis in the same platform.
There's a question you want me to ask. Can I field a couple questions for you?
Sure, absolutely.
So one question was, can you use this on existing Onshape models? So I think the answer is
yes, absolutely. You might have to. It will change your design intent in some ways, like the way that you developed your model. Let me take a look at this. Okay. I should have explained this as I was going through it, but so the way this works is you go into your Onshape model and you declare a variable, and when you go into your CADWOLF model and you link to the CAD, the variable name that you send, like I've sent outer radius and strut length there. When you save this file, or when you choose to just push the data to the model, it's going to push it for that same variable name. So all you do is you go into your Onshape model, create a variable of the same name, and then once you push it from that CADWOLF document, it will update in Onshape. So it will work with existing models, but you're going to have to declare variables and set up your models to accommodate them. So let's say when we extrude this rod out to its length, you have to set that variable to read it in.
cool. Let's see this question. Instead of individual parts, how does this apply to 3D printed pieces? I'm not sure this is the right question. It sounds to me like going from 5 to 6 parts to 1 part is really more of a Onshape workflow functionality question than it is CADWOLF necessarily. So
I don't think you can create variables in assemblies in Onshape, right? Am I just making that up?
You cannot. You are correct. That is true. But the difference between an assembly and a part studio right now is small. But yeah, that's actually one of the best reasons for CADWOLF to come in is you fulfill that functionality.
I would encourage you to have for each part to have a separate CADWOLF document, and that sort of helps you design that part just within that document. And then I personally don't like to have more than one single part in my part studio. It makes it easier for CADWOLF and other things to ensure that the mass properties you're pulling in actually match the part that you want, as opposed to maybe a couple of parts or something along those lines.
What's the cost, Joshua? You didn't talk about the business model here.
Well, so right now it's a recurring fee of $12 a month. There's also, it's basically free if you're using it for non-commercial purposes. It's also free if you're just learning. We do ask, obviously, that you provide feedback. If you find something some functionality you would like to have added, or maybe you find a bug, just let me know.
That seems very reasonable. Let's see. What about someone's asking about comparing it to MathCAD? I'm not sure exactly what, but is there any significant difference between a MathCAD and CADWOLF, or anything that sticks out?
I don't do a lot of the higher end math yet that MathCAD does, and I don't really intend to do a lot of symbolic integration. MathCAD does math very, very well, obviously. There are things that MathCAD, in my opinion, doesn't do well. Actually, going back to the math, so all of the math you see here is solved purely within the browser. It's all JavaScript, a browser solution. That does limit the type of math and the size of the matrix that you can deal with. It doesn't limit it as much as I had initially worried it would, though. You can solve math on pretty large matrices just in the browser, and it doesn't take long at all. So they're going to be a little heavier on the math aspect. What I'm working on right now is a server-side solution to where I'll be able to do more complicated math and larger problems. It's just when you hit enter to solve that equation, the solution will be done on the server as opposed to within the browser. There are a few things that I know from using MathCAD myself that MathCAD, at least in my opinion, didn't really do that well. Let me show you an example. We do have a 3D chart section.
Oh.
So if you've got, say, a matrix of data, you could plot a surface map. And you can plot lines and all sorts of things in here. So we do that, in my opinion, easier and better. This is all done with an open source project called 3.js. So this is all native JavaScript that runs off your graphics processor. That matrix you're looking at is, I think, 76 by 76, so it's not very big. In addition to this, we have MathCAD has this too. I didn't really like the way they did it though, but we have for loops, while loops, and if statements. So if you were to add one of these, you would see, just as you would in a computer program, sort of an if-else statement, and you can edit that statement and add equations to it, something along those lines. So it's easier to run a loop, to run an if-else statement, that sort of thing.
Yeah, it's very cool. Units alone make it worth it. I just always use them for unit conversion because I'm too lazy to do the math myself.
Yep.
I love that. All right. Does anybody else have questions? I think we always like to err on the side of keeping it short. I would suggest everyone go try the product and start using it. It's available now in the App Store, so there's nothing keeping you from popping in there and start driving your models with equations. Let's see. One thing we should do, I actually said we are going to do this at the beginning and I always spaced out. I didn't do a poll, but how about just out of curiosity, how many of you use your hand, you can raise your hand, about how many of you use MathCAD or Excel or something with equations and CAD together today? Is that something that you're doing, or is this new? And I'm just going to watch the hands that are being raised to kind of get a feel for how common this is. So any tool, it doesn't really matter which one, but just the idea of using some equations to drive your models and manage it and stuff like that. So it looks like about half the people in there are doing something like that. So that's about, I would assume that's about right. Yeah, feels right. Okay, so unless anyone has any more questions, I think that we could leave it there and give you guys a few more seconds to type in a question if you have them. Otherwise, we're good. All right, Joshua, thank you.
Thank you.
And let us know. Send us an email if you guys have any questions. Bye-bye.
Thank you.
If only I could figure out how to turn it off. Hold on, I'm getting there. That's funny. All right.